Hi students, welcome to today's class. Today I am going to explain a very basic fundamental concepts. Okay, I will give the proof for them also. Okay, now. So let us see the first concept here. The concept is the difference of the focal distances of any point on the hyperbola is equal to the transverse axis. What we have to prove is, let P is any point on the curve, that is especially hyperbola, S dash P that is S dash P minus SP, that is a difference of the distances, focal distances, is equal to the length of the transverse axis. Length of the transverse axis means what? See here, A dash up to here, this is called transverse axis. The length means we have to take the distance between the vertices, that is namely A and A dash, that is equal to 2A. This you have to prove it. Okay, now. So let us prove this. So see the proof here. Very easy, that is S dash P minus SP is equal to 2A. So very easy proof. So let us take that by definition. We know that let P be any point on the hyperbola, then we have SP by PM is equal to E. This implies SP is equal to EPM. Similarly, we have SP by S dash P. So here S dash P, from here I am multiplying S dash P by PM dash. PM dash is also E. Here I am taking second directrix. Okay. Now, from this S dash P is equal to E into PM dash. S dash P is equal to E into PM dash. From these two things I will subtract. S dash P minus SP is equal to E times, this is a PM dash minus, PM dash minus PM. Okay, PM dash minus PM. Let us see from the diagram. From the diagram, let us see what happens. PM dash minus PM is equal to how much? See here. PM dash minus PM is nothing but MM dash. E times MM dash. E into your MM dash is nothing but Z dash, that is distance between the directrix. Z dash. That is E into Z dash is equal to how much? Distance between the directrix. Distance between the directrix, we know that 2A by E. 2A by E. That is E get cancelled, 2A nothing but length of the transverse axis. Transverse axis. That's all. So from this, the difference, generally sometimes in some textbooks they will keep it a modulus. Why? Because here sometimes students may take this as S dash and this as a S, whatever may be that, they will take it as a modulus since it is a difference. So S dash P minus SP is equal to 2A. That is the difference. So if you take the difference of the focal distances of any point on the hyperbola, that is equal to the length of the transverse axis. Okay. Now we are going to find out the only one single focal distance, that is SP. What is the length of SP? That we are going to see here. Okay. So now we are going to see the focal distances. Okay. Right. Let us see that. Dear students, I am going to find out focal distance of a point. Okay, so let us see that concept. So what is the focal distance? So it is a distance between a point, that is let Px1 comma y1 is a point from the focus. That means we are going to find out the distance between S and P. How much the distance between S and P. Okay, now let us see that. So to do this concept, let us draw the perpendicular, Pn on the x-axis. Let us draw the perpendicular PN on the transverse axis. Okay, now, right, we know that by definition SP by PM. So, let us take this distance between, we know that SP by PM is equal to E. We want the distance SP, that is equal to E times PM. Understand? SP is equal to E times PM means how much here? So, this PM is nothing but, so I have drawn a perpendicular from P on the axis. So, from the diagram, PM is nothing but NZ. PM is nothing but NZ. That is, E is equal to, always take C as a central point. All the distances you take from the center. Why? Because here C is origin. C is, we are considering it as an origin, 0, 0. Right. We want NZ. We want NZ means what? Cn minus Cz. Cn minus Cz. So, we want Zn or Nz, total Cn minus Cz. So, this is equal to E times Cn is nothing but your x1 coordinate. That means here if you are writing x1 comma y1 means what? The length of Cn is x1. So, this is a x1 minus Cz. Z is nothing but foot of the perpendicular from the center on the directrix. So, therefore, Z point we know that AE comma 0, sorry, A by E comma 0, A by E comma 0. Therefore, Cz is nothing but A by E. Okay, na? So, multiply inside Ex1 minus A. This is the focal distance Ex1 minus A. Okay, now this is one focal distance. Okay. Similarly, so if you want to find out this distance S dash P. So, if you want to find out S dash P distance, now S dash P by PM dash. So, this now you will take here. So, this is PM dash. So, S dash P by PM dash is equal to E. S dash P is equal to E PM dash, E times PM dash. PM dash is nothing but NZ dash from the diagram. NZ dash E into NZ dash is nothing but Cn plus Cz dash. Cn plus Cz dash. That is E into Cn is nothing but your x1 plus Cz dash is nothing but your A by E. So, here actually x is equal to minus A by E, but you have to take the distance. Okay, that is plus A by E. So, you multiply Ex1 plus EE cancel. So, this is your S dash P. That means, so if you find out the distance from one focus, that is a nearby focus, then that is the distance is Ex1 minus A. So, if you find out the distance from the point to the far away focus, that is a S dash, that is given by Ex1 plus A. Okay, now I hope that you understand this concept. Okay, now so let us move to next concept. Welcome to this concept. The concept is here. The length of the lattice rectum of an hyperbola x square by a square minus y square by b square is equal to 1 is 2b square by a. Now, we are going to see the proof. Before seeing the proof, let me explain what is a lattice rectum. So, lattice rectum is a focal chord. Lattice rectum is a focal chord which is perpendicular to the axis of the hyperbola. So, this is axis of the hyperbola. That is one definition. Another definition is, so lattice rectum is a double ordinate passing through the focus. Lattice rectum is a double ordinate passing through the focus of the hyperbola. Like that also you can define. Now, that is L dash, the length of L to L dash. So that is, we are going to prove that L dash is equal to 2b square by a. So 2b square by a, where a is semi-transverse axis, b is semi-conjugate axis, that you know, right? Then how to proceed? Now see here, the point L is on the on the curve. The point L is on the curve, just like a p x1 comma y1. Now according to the definition of the eccentricity, we have SL by LM is equal to E. SL by LM is equal to E. That means SP by PM. In place of P, L is there. So this implies SL is equal to E times LM, cross multiplication. From the diagram, LM and SZ both are same. LM and SZ both are same. LM is equal to SZ. So E is equal to, already I told. So whatever may be the distance, you calculate from the center. Take center C as a base point. Okay now. So we want SZ length. This is nothing but CS minus CZ. CS minus CZ. Whatever may be the length, from center you calculate. So this is equal to E times CS means what? S already we know that foci, that is AE comma 0. Foci AE comma 0. Therefore this is a AE minus CZ. CZ is nothing but X is equal to A by E. X is equal to A by E. So this is nothing but A by E. Now you multiply inside with the E. So what you will get? A E square minus A. A E square minus A. Take A common outside. So if you take A common outside, E square minus 1. Already we know that when x square by a square minus y square by b square is equal to 1, we know that b square is equal to a square into e square minus 1. B square is equal to a square times e square minus 1. Now you divide with a on both sides. This is nothing but a into e square minus 1. So therefore a times e square minus 1 is equal to b square by a. Okay. So this is nothing but b square by a. So what is SL? SL is nothing but semi-lattice rectum, half of the lattice rectum. Therefore L dash is equal to 2SL, that is a 2b square by a. 2b square by a. Okay. So that's all the proof. Very easy proof. I hope that you understand this proof. So let us go for one more concept. So let us see what is the concept is trace of the curve. Trace of the curve, what is the curve means? X square by a square minus y square by b square is equal to 1. Trace means what? What is the nature of the curve? How it look like? So where it will be there? So what are the how it will be? What is the shape of this curve? All those things we will see now. Okay. So this is a hyperbola x square by a square minus y square by b square is equal to 1. So from this we can write down y square by b square is equal to x square by a square minus 1. So from this y square is equal to b square into x square by a square minus 1. Okay now. So this is a b square minus x square. So we can write it as a y square is equal to b square by a square into x square minus a square. On the whole, y is equal to plus or minus b by a square root of x square minus a square. So on the whole, I wrote y as a subject. Y is equal to plus or minus b by a root of x square minus a square. Now let us see here. For example, this x square minus a square is less than 0. Actually, it is under square root. It should be greater than 0. If possible, let there is a chance if x square minus a square is less than 0, then we know that x lies between minus a and plus a. X lies between plus minus a plus a. That means here already we know that the coordinates of this is a comma 0, this is a minus a comma 0. That means whenever x square minus a square value is negative, then a the curve lies between plus a and, so this a and a dash. But we know that always x square minus a square should be greater than 0. That means there is no curve between minus a and plus a. That's all. So if means plus x square by a square minus y square by b square is equal to 1, no. So here a is there, no. There does not x square down a square, denominator quantity a. So there won't be any curve between minus a and plus a. So that means in this area, there won't be any curve. From minus a to plus a, there won't be any curve. That is the first thing we have to remember. Right. So if you see here, as x value increases, automatically y value also increases. See here, if in this equation, y is equal to plus or minus b by a root of x square minus a square, as x value increases, y value is also increasing. So see here, if x value is increasing, corresponding to y value is also increasing, and moreover, so you observe here, for every one x value, since it is a square root, you are getting plus or minus. That means for every one x value, you are getting two y values. For every one x value, you are getting two y values. That means, for example, if you take x is equal to some 4, square root of 4, a value something. So square root of 4 means what? Plus or minus 2. That means y you are getting two values. That means for every x value, you are getting two x value which are from equidistance from this x value. Okay. That means the curve is symmetric about x-axis. And it does not lie between a and a dash. Then what will be the shape? So definitely that will be the shape of the curve. Okay now, right? So as x increases, y is also increases. If as x decreases, y is also decreases. Okay now. So if x value is going on increasing, so according to that, y value is also increasing. So if you come, so increasing means this side increasing. As x value increasing, y value is also going on increasing. If x value decreasing, y value is also going on decreasing. Okay now, right? So I hope that you understand this concept. Let us see some more concepts. Welcome to this concept. So now we are going to see some notations which are very useful in our coming classes. So the first one is the equation of the hyperbola is x square minus y square by a square minus y square by b square is equal to 1. Let there be 2 points x1 comma y1 and x2 comma y2. Then the algebraic expression, so that is x square by a square minus y square by b square minus 1. Remember that it is not equal to 0. So this is an algebraic expression with two variables x and y, x square by a square minus y square by b square minus 1. This is denoted as s. Don't say that s is equal to 0. Here there is no 0. Okay, only the expression x square by a square minus y square by b square minus 1. Okay, now first notation s1 means, x1 means, see here, always remember s1 means wherever x square is there, put xx1, y square is there, put yy1. If x is there, x plus x1 by 2. If y is there, substitute y plus y1 by 2. So these are the notations for s1. s1 means wherever x square is there, put xx1. Y square is there, y1. So x is there, x plus x1 by 2. If y is there, y plus y1 by 2. Okay now, right? That is a notation for s1. So here x square is there, that's why x1 upon a square minus y1 upon b square minus 1. Don't write is equal to 0. I am not writing is equal to 0. Just I am telling what is s1. Similarly, where x1, y1 is any point, Okay, afterwards we will tell that what is that point where that may be on the curve, may not be on the curve, or interior of the curve or exterior of the curve. Now coming to S2, okay, S2. So x2 means x2 upon a square minus y2 upon b square minus 1. Now S12, so that is x1 x2 by a square minus y1 y2 by b square minus 1. This is a S12 notation. The last and final S11 means x1 square by a square minus y1 square by b square minus 1. Almost similar to our notations in circles, parabola, hyperbola. So this ellipse, almost all notations are same. Okay, now for particularly S1 notation B, we should be very careful. Okay, right. I hope that you understand these notations. Using these notations, now we are going to see. So given a point, how to decide whether it is the interior of the hyperbola, exterior of the hyperbola. Let us see that. So if you observe here, hyperbola is a open curve. Then how to decide which is interior and which is exterior? Okay, so don't go away. So let us see that concept. Welcome back to this concept. Let us see what is interior and exterior of a hyperbola. Unless it is a circle, if it is a circle, sorry, this is a circle and it is a ellipse, both are closed curves. We know that what is interior, what is exterior. So even a small child also can tell. So this is the interior part. So this is also interior. Here also it is interior. Outside is exterior. So here also outside is exterior. This is interior, here exterior. This is interior, it is exterior. This, since they are open curves, sorry, closed curves. But hyperbola is not just like that. It is a open curve. It is a open curve. So this is a focus, this is focus dash. Then which you defined which is a interior and which is exterior. How the mathematicians they defined what is interior and what is exterior. So the first definition is the first definition is the region between the curve and the axis. The region between the curve and the axis. Axis, I am telling axis means what? Which intersects the curve. That means here transverse axis. The region between the curve and the axis. See here, what is the region between the curve and axis here? So this is the curve and this is axis. So this is the region. This is defined as interior. So here also it is a curve and it is a line. So this is interior. So this is interior of the curve. That is like that. So if it is an interior, the remaining part is exterior. Remaining part is exterior. That means outside is exterior. This is one of the definition. Another definition of the interior of the hyperbola or interior of the parabola also. Why? Because both are open curves. The region which has focus. The region which has focus. See here it is a focus is there. So here also it is focus is there. Here also it is focus. Therefore, this is the region which has the focus. Since the region has the focus, therefore it is called the interior of the region. So once it is we defined interior, automatically the exterior of the curve we can easily define. Okay, now so this is a very nice concept. Now what we are going to see is, given a point P x1 comma y1 and equation of the hyperbola, some x square by a square minus y square by b square is equal to 1. How to say that without tracing the curve, how to decide the point P belongs to either interior or exterior or on the curve. On the curve we can say that. So we can substitute the point in the equation. If the equation is satisfies, then we say that the point lies on the curve. But how to decide, given a point P x1 comma y1, whether it belongs to the interior or exterior? So let us see that, as our notation is a very, very important notation. So let us see that. Welcome back to this concept of very, very important concept. given a point, let us take a point x1 comma y1 and equation of the hyperbola x square by a square minus y square by b square is equal to 1. And how to decide whether this point, so without tracing the graph, for example, so you are given one point some minus 2 comma 3 and some x square by 4 minus y square by 3 is equal to 1 hyperbola is given. Then how to decide whether the point belongs to either interior or exterior. Okay, then how to decide without tracing the graph? With the tracing the graph, anybody can tell. But without tracing the graph, how to decide? Okay, that we are going to see here. See here, let us take the equation x square by a square minus y square by b square is equal to 1. So this is nothing but x square by a square minus, see here this, so here center, Cn is x, Pn is y. Cn, the length of C to the n is, let us draw the perpendicular. Let us take a P x comma y by x comma y be any point on the curve. Therefore, Cn length is x, Pn length is y. So, therefore, y is nothing but Pn square by b square is equal to 1. So, this implies Pn square by b square. Pn square by b square is nothing but x square by a square minus 1. So, this implies Pn square is equal to b square into x square by a square minus 1. Okay. So, therefore, Pn square is nothing but b square into x square by a square minus 1. That is, everybody knows. That means y square is equal to b square into x square by a square minus 1. Now, let us consider a point Q. Let us consider a point Q x1 comma y1 which is interior of the hyperbola. Let us consider q x1 comma y1 which is interior of the hyperbola, right. So, from the diagram clearly Qn is less than Pn, right or wrong? Qn is less than Pn. Since Qn and Pn both are positive quantities, why? Because the distances, we can clearly write down Qn square less than Pn square. Okay, now we can squaring on both sides. Since they are positive quantities, so less than will become as it is. So, this implies Qn square is less than, what is Pn square? Pn square means how much? B square into x square by a square minus 1. Understand. What is Qn? Qn is nothing but y1. Qn is nothing but y1. So, that is equal to y1 square is nothing but b square into. So, here we can take it as a x1. Why? Because if you think that the point, if it is here in place of px1 y1, we can replace x with the x1, no problem. So, no problem here. Why? Because the x coordinate is same. So, here also x and x1 both are same. So, here x and x1 both quantities are same. Why? Because here for q point x coordinate is x1, for p point x coordinate is also x, and x1 are both are same. That is why in place of x we can replace with x1, no problem. So, b square into x1 square by a square minus 1. Okay. So, let us simplify this equation. So, this is a y1 square by b square minus x1 square by a square plus 1. So, this is equal to, see here, y1 square minus b square by x1 square minus e square. If you comes this side plus 1 less than 0. So, understand this. So, see here p1 square we are taking to that side and plus 1 we are taking to this way. So, y1 square minus, so just you multiply with the minus sign, otherwise you can get like this, x1 square by a square minus y1 square by b square minus 1 greater than 0. So, I have multiplied with the minus 1 on both sides. So, x1 square by a square minus y1 square by b square plus 1 minus 1 automatically less than will become greater than. Now what is this notation? Already just now I have given this notation. X1 square by a square minus y1 square by b square minus 1 greater than 0 means S1 is greater than 0. S1 greater than 0. Okay now? So not S1, sorry, S11. S11 is greater than 0. So if S11 value is greater than 0, then the point lies inside the hyperbola. Okay now? Automatically, for example, how to prove that if the point lies outside? If the point lies outside, but means here q x1 comma y1 is here. Now q outside the line. Then whole thing will come. So here q1 is greater than pn. q1 is greater than pn. See here qn is greater than pn. I am proving for the outside. If the point lies outside, q1 is greater than pn. So it is also greater than. So it is also greater than. So it is also greater than. So everything will be. So it is a less than, I think. It is greater than. Now it is less than. Now it is less than or equal to, sorry, less than 0. So that means if a point P lies outside, Q lies outside, then S11 is less than 0. If it is lies inside, greater than 0. So if you observe, this is for circle, hyperbola, ellipse and parabola. So quite it is a reverse will be there. But in that, if for this parabola and the ellipse, if S1 means inside, S1 means less than, if it is greater than outside. But here reverse will be there, reverse order will be there. If S11 is less than 0 means outside. If S11 is greater than means inside. Obviously, if S11 is equal to 0, the point lies on the curve, that is hyperbola. Okay. So I hope that you enjoyed today's class. With some more concept tomorrow's class, I will stand before you. Until then, all the best.